Hi everyone, so today we're going to go ahead and look at some of the basic trig identities. Now, something for you to remember is that an identity is something that's always true. So there are typically three types of questions that you'll have when you are working with trig identities. It could be simplifying expressions, working on one side of your equation to prove that it equals the other side, and then solving problems by substituting identities to make the problem solvable. So remember that our goal is for you to solve the problems, not to memorize any of the formulas. Now, just remember that you can sort of, rearrange or rewrite your problem to make it easier. You can move or flip or substitute parts of an identity to sort of match what you need. So we're going to go ahead and look at some of the identities here today. So the first identities we're going to look at are your reciprocal identities. So you want to sort of think about these as your flip tool. These are reciprocals of the trig functions that we know, right? We've got sine, cosine, tangent, and it's reciprocal. Now remember that these identities also will work if you square the function. You also have quotient identities. So you sort of think about these as like your substitute tool, right? So how can I sort of take these identities, replace them, with some other identities? Now, these also will work if you square the function. So let's look at some simplifying expressions in the next couple problems. So when I look at these expressions, I'm going to look at each part. So the first part I'm going to look at is cotangent. I can use one of my quotient identities and sort of substitute cosine of x over sine of x in place of cotangent. And then I can look at secant and I can say, oh, well, I know I could use one of my reciprocal identities, and I know that secant is the reciprocal of cosine. So that's 1 over cosine of x. And then I look and see, all right, how can I simplify what I have? Well, I know that my cosine of x's will cancel. So I have 1 over sine of x, which I know that's a reciprocal identity. 1 over sine of x is the same thing as cosecant of x. Okay, in question number 2, let's go ahead and look and see what we have. So we have secant squared of theta. So again, I'm looking at my reciprocal identity, and I know that even though in my reciprocal identity I don't have the square, I know that it will also work if I square my functions. So secant squared of theta, I know is the same thing as 1 over cosine of theta, but because my function is squared, I can put cosine squared theta. I'm looking at sine squared of theta, and I say, well, I can't really simplify that anymore, so I'm going to leave it as sine squared of theta. However, when I look at my question, I know that I have sine squared of theta over cosine squared of theta, right? So sine squared of theta over cosine squared of theta, I look at my quotient identities, and I could say, oh, well, I know that that is the same thing as tangent, but because it's squared, I can also write tangent squared theta. Okay, so here what we're going to do is we're going to look at some identities that we're going to verify. So when you're verifying trig identities, you want to make sure that you're just transforming one side of your equation and making sure that it looks like the other side of your equation. So you don't want to change both sides. You're only going to transform one. So if I look at cosecant, I know that's a reciprocal identity. That's 1 over sine of theta. And then I have another part, which is just cosine, so I can't really do anything with that, so cosine of theta. And then I have tangent of theta. Well, I know tangent of theta, that's one of my quotient identities, so that's the same thing as sine theta over cosine of theta. Now, when I look at what I have here, I have a cosine in the numerator, which cancels out with the 1 in the denominator. And then I have the same thing for sine in the numerator with the sine in the denominator. So I'm left with just 1. And I know that 1, I wanted it to equal 1. So I went ahead and was able to verify my identity. So in question number 4, we have cotangent and secant. So remember that our goal is to make my left side of my equation look like it has a cosine and a tangent. So I know that I have to somehow change cotangent and secant. So I know what I can do is I could do some rewriting here. So I look at cotangent, which is one of my quotient identities, And I know that cotangent is the same as cosine over sine. And then I'm going to add that to my secant. So secant I know is 1 over cosine of theta. I can go ahead and multiply, right? So I have sine theta cosine theta over sine of theta plus, I'm going to do sine of theta over cosine of theta. So remember, you're just distributing. All right, so let's go ahead and see what we've got. I know my sines cancel, so I have cosine of theta, which is one part that I wanted. And then I know that sine over cosine. I know that that's the same as tangent, which is the other part that I wanted. So I was able to verify this identity. Here what we have is we have some co-function identities. Now, the thing that we want you to sort of remember of what a co-function identity is. So it's one function of an angle that equals another function of its complementary angle. So if I give you just an example just to help you, you can imagine that you have, let's say we're in quadrant number 1. Okay, so let's say my theta, we're going to say for right now is, here's my theta. We're going to say that that is pi over 6. Okay, so I'm going to use the very first example. So pi over 6. So the sine of pi over 6, I know is 1/2. Okay, and that has to equal the cosine of its complement angle. So remember that complementary angles are angles that add up to 90 degrees, or in this case, we're looking at radians that will add up to pi over 2. So if I look at what I have, the complementary angle for pi over 6 right here is pi over 3. Okay, so, well, if I look at what I have for my identity, the cosine of pi over 3 is also equal to 1/2. Okay. So we can think about co-function identities being my sort of complement tool, right? So I'm thinking about complementary angles, right? They have to add to 90 degrees, or in this case, we're looking at radians, they have to add to pi over 2. Now, our odd identities and our even identities sort of go along with what we looked at in Unit 1, and it talks about our even and odd functions, very similar. So odd identities are sort of thinking about that the signs of my output are going to flip, right? So when I put, let's say, negative f of x, right? My negative function, right? That's so we know that my odd identities flipped my function. And for even identities, we want to just remember that it doesn't change. It does not change the output. So what I have is my answer is going to be the same as my just original function. Okay, so now let's go ahead and look at a couple examples when we're looking at co-function identities as well as even odd identities. Okay, so for question number 5, what I want you to think about is one of the co-function identities. Okay, so the one that you're going to look at is the one that says sine of theta, which matches to that, equals cosine of pi over 2 minus theta, which is what we have. Okay, so I know that if my sine of theta is negative 0.25, right, the complementary angle, which I'm looking at, also has to equal negative 0.25. So if I look at question number 6, I'm going to look at my even odd identities. So I'm going to look at the one that says tangent. So I have my tangent identity in my odd little column there. So the tan of negative theta has to equal negative tan of theta. Okay, so let's just compare what we have. If I know that the tan of theta has to equal a positive 4, so when I want to find tan of negative theta, well, I'm just going to have a negative and then the 4. So in question number 7, we're going to look at a combination of both of these identities. So I look at my first part, that's cosecant squared this time. Again, remember that these Cofunction and even odd identities also work if you square the function as well. So always make sure that you be careful and be mindful of that squared. So what we got here is cosecant squared of pi over 2 minus theta. So I know that's the same thing as secant squared of theta. In the second part, I've got tan squared of negative theta. Again, if I look at my odd identity, what I have is just negative tan squared of theta. So let's go ahead and simplify that. So what do I know? I know that secant squared of theta is the same thing as 1 over cosine squared of theta. And then what I also know for my negative tan squared theta, that is the same thing as sine squared theta over cosine squared theta. So again, what you're doing is you're also looking at quotient identities. You're looking at reciprocal identities and putting all these identities together. Well, what I can see here is that my cosine squares are actually going to cancel out, and I'm going to have 1 over negative sine squared of theta, which in this case I know is just cosecant squared of theta, and I got the negative there. So I'm going to go ahead and keep it. Now, I hope you found this video helpful and you're able to have a better grasp of trig identities. Don't forget to check out our next video on the Pythagorean identities. Thanks for watching and have a great day.